This is R.D. Sharma Solution Class 12. We are taking exercise 19.31 of chapter number 19, Indefinite Integrals. Now this kind of question is almost equivalent to the previous questions in the different exercises we have done. What was the process? X square equals to t, we will put t plus 1. In the numerator, denominator will be t square plus t plus 1. And we'll try to make the factor of the denominator and try to find out the partial fractions like a divided by some factor 1, b divided by factor 2. This already has been done. But the problem here is that this t square plus t plus 1, we don't have factor. We cannot have a factor in this case. Otherwise, we could have done in the previous way we have learned. So how to do this? Same thing, x square only we have to take, but we have to divide numerator and denominator by x square. So let's divide everything by x square. So x square by x square plus 1 by x square divided by x raised 4 divided by x square plus x square divided by x square plus 1 divided by x square. So this will come as 1 plus 1 by x square. Then we have x square. This 1 by x square I am writing first. So 1 by x square. And this x square get cancelled. You will only be left with 1. Now this denominator is well known to you. That is, if you take x plus 1 by x whole square, it will be a square plus b square plus 2ab, that is x square plus 1 by x square plus 2 into x into 1 by x, that will give you a 2. Same thing with x minus 1 by x whole square will give you x square plus 1 by x square minus 2. So in numerator we have 1 plus 1 by x square. We need this 1 plus 1 by x square. This will come from the differentiation of the denominator. So denominator is x square plus 1 by x square plus 1. So you can take x plus 1 by x whole square also. You can take x minus 1 by x whole square also. But since we need 1 plus 1 by x square in the numerator, we cannot have x plus 1 by x in the denominator. Alright? When you differentiate x plus 1 by x, it will be 1 minus 1 by x square. When you differentiate x minus 1 by x, it will be 1 plus 1 by x square. So we ought to have x minus 1 by x square in the denominator in order to get 1 plus 1 by x square in the numerator. Alright? So the second one we'll take here in this case. Let me explain you again. Denominator, you need x minus 1 by x whole square, because when you open it up, or when you differentiate x minus 1 by x, you will get 1 plus 1 by x square after differentiation. So x minus 1 by x square is x square plus 1 by x square minus 2. So this minus 2 will come extra, so you need to add an extra 2 here. 1 is already there in this question. So 1 plus 1 by x square divided by this content. Why we have done all this, you have understood now. That is, we are going to integrate with x square being divided and various aspects taken into consideration. 1 plus 1 by x square in the numerator and x minus 1 by x whole square plus 3. So x minus x 1 by x can be taken as t now. So when we differentiate it, dt by dx will give you 1 plus 1 by x square, which we wanted in the numerator, which is already there. So dt will become 1 plus 1 by x square into dx. This whole will come as dx. So this integration will become like this. 1 plus 1 by x square dx will be dt. Denominator x minus 1 by x was taken as t. So it will be t square and plus root 3 whole square, because 3 we wanted to have it in a square form. So root 3 whole square. So we'll use the formula dx divided by x square plus a square, which is simply 1 by a tan inverse x by a. So what is a here? Root 3. X will be t. So 1 by a tan inverse x by a comes from dx divided by x square plus a square. So 1 by a, that is 1 by root 3. Tan inverse, so t by root 3 will come. So this will be t divided by root 3. Now one more step is remaining. Initially t was taken as what? T was x minus 1 by x. So we'll put this x minus 1 by x here. We'll separate them out. X minus 1 by x divided by root 3. This will become x square minus 1 by x in the denominator with a root 3. So let me write the final answer after the integration. I will be equal to 1 by root 3 tan inverse x square minus 1 divided by root 3 multiplied by x, plus a constant of integration. Okay, this is your final answer. So this is how you're going to solve it. All this dividing numerator and denominator by x square, putting all these you have to follow. Now under root cot theta d theta. This is a 5 marks question. You'll see there will be more than 1 or 2 concepts we are going to employ here. First thing first, is eliminate the root. So take this t equals to under root cot theta. Let's square both the sides. T square will become equal to cot theta. Let's differentiate. 2t dt by d theta, we are differentiating with respect to theta on both the sides. 2t dt by d theta will be equal to minus cosec square theta. D theta you can bring on the, or you can take on the right hand side. So this 2t dt has become minus cosec square theta d theta. Now you will ask the question, why we have done this? Okay, we need d theta. So for that we need d theta here. So let's take this negative cosec square theta in the denominator. So it will be negative 2t dt divided by cosec square theta. But still cosec square theta is creating a problem here. We cannot have a t and theta together. Either t will be transformed to theta or theta has to be transformed to t. So there is a relationship between cosec square theta and cot square theta. D theta will be equal to negative 2t dt divided by cosec square theta is 1 plus cot square theta. But cot theta is t square, so cot square theta will be t to the power 4, t raised 4. So d theta has now become negative 2t dt divided by 1 plus cot square theta. Cot square theta has to be written as t to the power 4. So everything on the right now we have transformed into t. So 1 plus t raised 4 will come. Now come again here. I will become, see, under root cot theta was already t, minus 2t dt divided by 1 plus t raised 4 will be written in place of d theta. It will be 2t square, negative 2t square. dt was already there. 1 plus t raised 4 will come. So first thing, we'll take this negative outside. 2t square is what? T square plus t square. Because 1 plus t raised 4 is in the denominator, we will add a 1 and subtract a 1. So 1 plus this t square, which we have written as t square plus t square, we can add a 1, we can subtract a 1. So t square plus 1 in one case and t square minus 1 in one case, that will eventually form 2t square only. In the denominator we have 1 plus t raised 4. So I'll just divide these two into two different terms, which is t square plus 1 and t square minus 1 plus is already there in the denominator. We have 1 plus t raised 4 in the denominator, 1 plus t raised 4 in the denominator for both the content or both the terms. Negative is still outside. We have dealt with 2, but still negative is outside. So now I am multiplying negative inside and writing it. So first term will become negative integration of t square plus 1 and t raised 4 plus 1. Then minus, because we have already multiplied by negative, minus t square minus 1 divided by t raised 4 plus 1. And in both of these cases, they are to be integrated with respect to dt. Now divide numerator and denominator by t square as we have done in the question number 1, previous question. Divide every term by t square and see what do you get. So minus integration, this will be 1 by t square, this will be t square plus 1 by t square, minus this will be integration 1 minus 1 by t square divided by t square plus 1 by t square, and we ought to have dt in both the case. Okay, dt is already there. I'm not writing it. dt is already there. In the denominator, negative 2 plus 2. Here also negative 2 plus 2. In order to get 1 plus 1 by t square, you need to have t minus 1 by t in the denominator. So that's why we are writing this t square plus 1 by t square minus 2 as t minus 1 by t whole square. This will be t minus 1 by t whole square. Along with this, we have a plus 2 also. So we can write root 2 whole square in order to make it as a perfect square. Here also, 1 minus 1 by t square we need. For that, we need to have t square plus 1 by t square plus 2, that will form t plus 1 by t whole square, and minus this 2 will be root 2 whole square. You can just square it. 1 minus 1 by t will be there. 1 minus 1 by t square. So let's take t minus 1 by t as p, t plus 1 by t as q, and we will differentiate it so in order to get the numerator. So t minus 1 by t, as I earlier indicated, can be taken as p. T plus 1 by t can be taken as q, and now differentiate both the sides. So 1 plus 1 by t square will be equal to dp by dt. On the right, it will be 1 minus 1 by t square equals to dq by dt. So dp has come what? 1 plus 1 by t square into dt. dq has come as 1 minus 1 by t square into dt. Now if you remember, what was it? I indicated you earlier. So we are writing dp in this case. T minus 1 by t was taken as p. So this will be p square plus root 2 whole square. This is the first term. Then we have dq because 1 minus 1 by t square into dt was that. Now we have q square minus root 2 whole square. So this will come as what? Minus, it's basically dx by x square plus a square formula. So 1 by a tan inverse x by a, 1 by root 2 tan inverse p by root 2. Now coming to the second part or second term, integration of dx divided by x square minus a square, it will be 1 by 2a log x minus ax plus a. So 1 by 2 root 2, a is root 2, log x is q here. So q minus root t and q plus root 2 inside the modulus plus a constant of integration. But this p was what? Q was what? P was initially t minus 1 by t. Q was initially t plus 1 by t. So let me write it. Negative 1 by root 2 tan inverse t minus 1 by t divided by root 2. The first term. 1 by 2 root 2 log. In place of q you can take t plus 1 by t. So t plus 1 by t minus root 2. T plus 1 by t plus root 2 and plus constant of integration. Initially t was taken as under root cot theta, if you remember. T square was cot theta. That's what we are going to do. First we'll just simplify these two which are inside this tan inverse and log. Let me do it here only so that you have a better idea how it has transformed. This t minus 1 by t will be equal to t square minus 1 by t. So let me write it here. T square minus 1 by t will go in the denominator root t. Here also t plus 1 by t will form what? It will be t square plus 1 by t along with a negative root 2 and a plus root 2 in the denominator. So t square plus 1 minus root 2t divided by t. Denominator also will come like this. T square plus 1 plus root 2t divided by t. This will get cancelled. So I'm going to, what I've done here is quite clumsy. So I'm going to write it properly in the next step. So what we have got, this is minus 1 by root 2 tan inverse t square minus 1 divided by root 2t minus 1 by 2 root 2 log modulus of t square plus 1 minus root 2 t and t square plus 1 plus root 2 t inside a modulus sign plus a constant of integration. So t square was cot theta, t is equal to under root cot theta. Now we have to change this t term to the cot theta term. So negative 1 by root 2 tan inverse t square will be cot theta minus 1. This will be root 2 into t. T is what? Under root cot theta. Now this under root cot theta and under root 2 can be taken inside. Under root a into under root b is what? Under root AB. So under root 2 cot theta you can write. Minus 1 by 2 root 2 log t square is cot theta. So cot theta plus 1 minus root 2. T is under root 2 cot theta. Then we have cot theta plus 1 plus under root 2 cot theta plus a constant of integration. And this is your final answer. So this is, again I'm saying, there are multiple things which we have employed here. It's a very strong question that may come in your 5 marks. Now this one is x square plus 9 divided by x raised 4 plus 81. Same concept we are going to apply. First we will divide everything by x square. That is x square by x square plus 9 by x square divided by x raised 4 divided by x square plus 81 divided by x square. So this will be 1 plus 9 by x square divided by x square plus 81 by x square. Now you need to have a observation as per your previous experience. X plus 1 by x square was what? See, if you want a plus in the numerator, you ought to have a denominator in the negative sign. So if you write x minus 9 by x whole square, which I can see the denominator will come with this. If you square it, x square plus 81 divided by x square minus 2 into x into 9 by x. So this will form what? It will be x square plus 81 by x square minus 18. So we already have this x square plus 81 by x square. Let's subtract 18 and add 18. When you do this, the first 3 term in the denominator, 1 plus 1 by 9, 1 plus 9 by x square in the numerator remains the same. But this x square plus 81 by x square minus 18 will give you what? X minus 9 by x whole square, which I just showed you. And what is remaining? This is 18, so you can have a perfect square with under root 18. So under root 18 square you can write. Now simply you have to do the same thing which we have done in the previous 2 questions. Just take x minus 1 9 by x as t. Dt by dx will be 1 minus 9, 1 plus 9 by x square. It's not negative. There is a slight mistake here. 1 plus 9 by x square, which comes as the dt only. So they are same. So we'll write this numerator as a dt. Denominator is what? It will be only t. Please remember, this is not x minus 9 by, this is 1 minus 9 by x square. It is 1 plus 9 by x square. There is a slight change here. So it is t square plus under root 18 1 whole square. So the integration has become like this, dt divided by t square plus under root 18 whole square, and this is the formula which we'll use is dx by x square plus a square 1 by a tan inverse x by a. So this will be 1 by a is 1 by under root 18, a is root 18 only. Under root 18 is 9 into 2. And under root 9 into under root 2 you can write. Under root 9 is 3 only. So 3 under root 2 will come. 3 root 2. So it will be tan inverse t divided by 3 root 2. And what was t initially? It was x minus 9 by x. So 3 root 2 is already there. I am talking about what is inside tan inverse. So I am just resolving it. So x square minus 9 divided by x into 3 root 2 will come. That I can replace inside tan inverse. So the integration has become directly like this. 1 by 3 root 2 tan inverse x square minus 9 divided by 3 root 2x you can write. Plus a constant of integration. This is the final result. So this is how it can be done. For reference also I have given this solution for you. This question will be taken in the next discussion. Till then, thank you so much and have a good one.